To address the challenge set forth by Iron-Dev, the Grill settled on a UAV search and rescue simulator. Before development started, core requirements were debated and set. First and foremost, the simulation would be distributed and multiplayer. Second, a mission planning phase would allow flight paths to be drawn collaboratively in virtual reality real-time on a small-scale landscape. Third, an informal queue allows for participants to collaborate. Finally, the simulation could be used in both military and civilian contexts. Once core requirements were set, a small team set to work creating parts of the simulation in Unreal Engine. Users are presented with a main menu that allows a new game to be initiated. Users can host or join an existing game. For multiplayer, usernames are supplied and roles are selected for each user. An instructor-operator role allows for oversight and observation of the scenario, while UAV operators can control drones and identify found targets of interest. The UAV operators can be in either VR or in desktop. The number of drones is set. Note that the number of drones can and generally should exceed the number of users. Once all users have indicated readiness, the mission planning phase begins. Voice communication facilitates collaboration during all phases of the experience. Spawned into an Operations Center mobile tent, users are able to see and collaborate with each other in virtual reality. The Operations Center contains props and various displays upon which to conduct search and rescue operations. Importantly, the Operations Centers contain holographic mini display of the landscape. Colored drones can be grabbed in virtual reality and moved around the landscape to create flight paths. These flight paths can be edited and tweaked collaboratively to satisfaction. Once the scenario begins, drones will automatically follow their indicated flight paths. The environment is a large-scale and detailed landscape. Since developing such a landscape would require great time and effort, the landscape from the infamous Boy-in-a Kite Unreal Engine demo was used. Significant optimizations were needed to make the landscape performant and usable in small scale during the mission planning phase. We find the landscape to be representative of terrain and ecosystems that may be encountered during a search and rescue operation. Entities are placed pseudo-randomly throughout the level, which ensures a difference between each scenario. Entities consist of friendlies, neutrals, signs of life, and targets. Once the scenario is initiated, users are presented with several views. If an instructor is present, they are presented with a mini-map view and can freely fly anywhere in the map to observe progress. An overhead map view with flight trails and flight paths provides continual situational awareness. Any drone's view can be passively observed by a user at any time. A tiled view with up to 4 drone feeds is available to each user. Users are free to toggle the 4 video feeds, and any feed can be expanded to full screen to provide a larger view. Operating the drones is a critical function of the simulation. While the drones default to automatic waypoint flight as dictated by their flight path, a user can override and manually fly the drone at any time in the simulation. When a drone is overridden, visual indication is given and the owner of the drone's username overlaid to the feed. Identifying objects of interest is the chief goal of users in the simulation. Objects can be identified in 2 ways, semi-automatically or manually. Semi-automatic is engaged when the drone is flying a prescribed flight path. Simple object recognition is used in this case and a picture of the object is taken. If a drone is manually piloted, users can take the pictures at will. Any object of interest is inserted into a shared log that is viewable by all users. If an object of interest is created automatically, then a user must navigate to the queue and disposition the object appropriately. If the object is manually created, the creating user can disposition it before insertion in the shared log. Objects can be dispositioned as signs of life, neutral, friendly, or a target. Each entry in the shared log contains an expandable thumbnail picture. Users work collaboratively to observe the drone feeds, manually override flight, find objects of interest, and disposition the log. The Grill believes the simulation could be the foundational framework for studies in distributed search and rescue reconnaissance. Everything seen is fully functional and developed from scratch in a short period of time. Although 7 total developers worked on the project, when time is added up, about 2 full-time equivalents worked on the project over the course of several weeks. To speed up development, a variety of plugins were used. The VR expansion plugin, which allows for multiplayer VR, Don's AI navigation, which allows for flight AI navigation, the SmoothSync plugin, which allows for smoother multiplayer replication, a Boy-in-a Kite demo, which is the demo that the main landscape was pulled from, and the Advanced Session plugin, which allows for more flexibility when hosting or searching for multiplayer sessions. A variety of content, mostly free and some paid, was harvested from the Unreal Engine marketplace. Examples include character models and animations and signs of life. There are several areas in which the simulation could be improved on. Introduction of real-world geospecific rather than geotypical landscapes would greatly improve the utility of the simulation. Voice communication is currently provided by an outside system rather than natively supported within the sim. Additionally, the mini-map could be enhanced to geographically show where pictures were taken and allow for direct interface to the shared log from the mini-map. The Grill is privileged to participate once again in Iron-Dev, and we hope that you have enjoyed learning about our project as much as we enjoyed creating it.